Determinants in matrices topic. I think this is the fourth chapter. We are in that determinants. In that exercise 4D, we are discussing about adjoint matrix and inverse of a matrix. In the last class, we discussed about cofactors of a matrix. What is the meaning of adjoint of a matrix? The transpose of cofactors matrix is called adjoint matrix. Adjoint of a matrix. This is the definition. Simple definition, dear students. What is adjoint matrix means? The transpose of cofactors of a matrix is called adjoint matrix. Okay. After knowing the definition, it is denoted by adjoint of A, or sometimes capital A also they will use, but generally this is the way, dear students. Okay. See, for example, if capital A equal to small a, small b, small c, small d. For this, how to calculate adjoint of a matrix? For that, we need to calculate for every element of this matrix, we need to calculate cofactors, no? So, cofactor of elements. So, for A11, cofactor, capital A11 is equal to, so eliminating of this row, this column, so A22 element, and here minus 1 whole power, cofactors means, into minus 1 whole power 1 plus 1, it will be A22 will come, dear students. Next, A12, minus 1 whole power 1 plus 2, so eliminating of this row and this column, A21 will come. So minus A21. Next, A21, for this element cofactor we are calculating, eliminating of this row and this column, minus 1 whole power 1 plus 2 into A12, that is equal to minus A12. Next, A22, minus 1 whole power 2 plus 2, eliminating of this row and this column, A11 will come. Therefore, A11. So, therefore, cofactor matrix. Cofactor of capital A equal to. So, first A11, A12, A21, A22. So, adjoint matrix means what? Adjoint of A is equal to transpose of cofactors only, no, dear students. Cofactors of A. So, transpose of this matrix. A11, A12, A21, A22. Transpose. So, adjoint A equal to, adjoint of A equal to A11, A21, A12, A22. This is called, what is the values? We already done that values. A11 means A22. Next, A21 value is minus A12 according to this, dear students. Next, A12 value minus A21. Next, A22 value A11. A11 is A. So, adjoint of A equal to A22 value is what? A22 value is D. Next, A11 value is A. Next, minus A12 value. A12 value is B. Minus A21 value is C, dear students. C. So, adjoint of A. If A is A, B, C, D, adjoint A will becomes, from this note, if A equal to A, B, C, D, then adjoint A can be written as, see, this value, interchanging of columns, that means principal diagonal, interchanging of these two elements. So, D, A. Sign changing of this diagonal, minus B, minus C. I hope you understand. So, for example, the question we will start it. Exercise 4D, question number 1. Find adjoint of a matrix. Find adjoint of a matrix. 1, 2, 3, 4. So we need to take the proper steps. So this procedure no need to write. Why? Because we have to apply this formula. We need to formulate this one. Whenever you know the procedure, after knowing the procedure, you have to apply this one. Based on the marks, if it is 2 marks or 4 marks, based on the steps, you have to write it. So let A equal to 1, 2, 3, 4. So adjoint matrix, then adjoint A equal to interchanging of diagonal elements. So 4 will be here, 1 will be here. Sign change of these two, minus 2, minus 3. This is over. Otherwise, what we have to do is, or cofactor elements. So cofactor elements is plus, minus, plus, minus, plus. Okay. First, we have to calculate for all cofactors. Cofactor of 1. Cofactor of 1 equal to 1 means this position is minus 1 whole power 1 plus 1. And if you eliminate this row and this column, 4 is the remaining into 4. So it will be 4 only. Why? Because minus 1 whole power 1 plus 1. Cofactor of 2 element. So what is this 2 element? Minus 1 whole power 1 plus 2. First row, second column element. If you remove these two, 3 will be there, no? So minus 1 whole power 3 is minus 3 will come. Next, cofactor of 3 element. Minus 1 whole power, second row, first column element. 2 plus 1. If you remove this row and this column, 2 will be remaining. So minus into 2, minus 2. So cofactor of 4. Minus 1 whole power 2 plus 2. Eliminating of this row and this column, 1 will be there. So which is equal to 1. Now I am writing cofactor matrix. So cofactors of capital A. So what we have to write it is 4 minus 3 minus 2 1. Later adjoint A is equal to transpose of cofactors matrix. So that is equal to transpose, you need to do that. 4 minus 3 minus 2 1 we have to transpose. So 4 minus 2 minus 3, 1. Even if you do this answer only, we got it? No. This answer and this answer both are same. This is by using the procedure. This is by using this formula, dear students. The two variants I am explaining according to your convenience, you can make it. I hope you understand. We'll move to question number 2. This question number 2, find the adjoint of question number 2. Find the adjoint of the matrix. Here 3 by 3 determinant, dear students. 1 minus 1, 2, 2, 3, 5, minus 2, 0, 1. So step by step we will discuss. First we need to calculate for all cofactors. Cofactor of 1, minus 1 whole power 1 plus 1, 3501, which is equal to 3 minus 3. So cofactor of minus 1, minus 1 whole power 1 plus 2, determinant of eliminating of this column and this row, 2, 5, minus 2, 1. So minus 2 minus of minus 10, 2 plus 10, 12. Next cofactor of 2, minus 1 whole power first row, third column. So eliminating of this column and this row, 2, 3 minus 2, 0. So minus 1 whole power 4 is plus 1, 0 minus of minus 6 plus 6. 6. Next, cofactor of 2, minus 1 whole power 2 plus 1, second row, first column. Second row, first column eliminating, minus 1, 2, 0, 1. So this is minus 1, 0. So plus 1 will come. Next, cofactor of 3, minus 1 whole power 2 plus 2, eliminating of this row and this column, 1, 2 minus 2, 1, 1 minus of minus 4, 1 plus 4, 5. Next, cofactor of 5, minus 1 whole power 2 plus 3. So eliminating of this row and this column, 1 minus 1 minus 2, 0. So minus is there, 0 minus 2. So already minus is there, 0 minus AD minus BC, 2. So it is equal to plus 2. Next, cofactor of minus 2, minus 1 whole power, 3 plus 1. Third row, first column. Minus 1, 2, 3, 5. So minus 1 whole power 3 plus 1 is 4. Plus 4 means it will be positive. Minus 5, minus 6, minus 11. Next, cofactor of 0, minus 1 whole power 3 plus 2, determinant of eliminating of this row and this column, 1, 2, 2, 5. So minus 5 minus 4, 1 will come. Next, cofactor of minus 1 whole power 3 plus 3, eliminating of this row and this column, 1 minus 1, 2, 3. So minus 1 whole power 3 plus 3 is 6. Minus 1 whole power 6 is positive. 3 minus of minus 2. 3 plus 2, 6. 3 plus 2, 5. I hope you understand. All cofactors we calculated. So adjoint, directly I am writing adjoint A equal to transpose of cofactors. So cofactors, you write it, 3 minus 12, 6, 1, 5, 2, minus 11, minus 1, 5. So the transpose of this matrix, 3, 1, minus 11, minus 12, 5, minus 1, 6, 2, 5. So this is the way we can get the answer, dear students. So you can check it out. 3 minus 12, 6, 1, 5, 2, minus 11, minus 1, plus 5. I hope you understand. Alternatively, what we have to do is, see, first you take it one matrix, you start with 3, 3, 5, 2, again 3 you have to write it. Next 0, another method, 0, 1, minus 2, again 0. Next go to first row, minus 1, 2, 1, minus 1. Again you have to write the first row, 3, 5, 2, 3. Here, very important thing. So like this, you have to find out the debts. 3 minus 0. So 3. Next, minus, for this transpose you need to calculate. 3, next minus 10, minus 2, minus 12, 0, minus of minus 6, plus 6. Next, 0, minus of minus 1, plus 1. I'm writing like this. 1 minus of minus 4, 1 plus 4, 5. 2 minus 0. Minus 5 minus 6, minus 11. 4 minus 5, minus 1. 3 minus of minus 2, 3 plus 2, 5. The transpose of this matrix. So 3, 1, minus 11, minus 12, 5, minus 1, 6, 2, 5. I hope you understand. This is the alternate method which we discussed in the, this is a shortcut formula. You can apply as a shortcut if you want for a joint. Okay, dear students, I hope you understand. We'll move on to other question. Other concept we will go. What is that other concept? Inverse of a matrix. Inverse of a matrix. Inverse of a matrix. So inverse of a matrix is denoted by like this. 1 by det A into adjoint A. This is the formula to calculate inverse of a matrix. You know that how to calculate adjoint A and all. For example and exercise problems, so we will take it now. Find question number 3, dear students. Find the inverse of the matrix, inverse of the matrix 2 minus 2, 4, 3. Similarly, question number 4, find the inverse of the matrix minus 1, 5, minus 3, 2. So first what we have to do is we can find out the determinant. So let A equal to 2 minus 2, 4, 3. That implies det A or determinant of A equal to AD minus BC. 2 into 3 minus 4 into minus 2. 6 plus 8, which is equal to 14, det A equal to. After that, adjoint of A. Adjoint of A can be written as, I already given shortcut formula, dear students, for adjoint A. Just once again I will show that. This is the adjoint A. If A equal to A, B, C, D, then adjoint A equal to interchanging of diagonal elements and sign changing of non-diagonal elements. So adjoint A equal to interchanging of diagonal elements 3, 2 and sign changing of here plus 2 minus 4. Therefore, A inverse is equal to 1 by det A into adjoint A. So, which is equal to 1 by 14 into adjoint A matrix. 3, 2 minus 4, 2. This is the way we can calculate. Sandeep, thank you for the joining the session. Yeah, if you like this video, please like and it reaches to more students. Even any requirement is there, you can share to write in the comment box. In my free time, I will see and I will cover that concept or topic. Okay. So find the inverse of this matrix. Let us consider this matrix is A. Let A equal to minus 1, 5, minus 3, 2. So immediately find out the determinant of A. So we know that A, B, C, D, if a 2 by 2 matrix, then whose determinant is AD minus BC. So minus 1 into 2 minus 3 into 5. So which is equal to minus 2. Minus into minus is plus, 5 into 3 is 15. 15 minus 2 is 13. So det A equal to 13. Next, adjoint of A. So adjoint of 2 by 2 matrix, you have to use this formula instead of this procedure. Even this procedure also explained. But instead of that, if A equal to A, B, C, D, then adjoint A is interchanging of these two elements, diagonal elements, and sign changing of non-diagonal elements or half diagonal, off diagonal. So adjoint of this matrix is 2 minus 1, interchanging of these two and sign changing of this one. This is plus 3 minus 5. Therefore, inverse of a matrix, A inverse equal to, write formula 1 by det A into adjoint A. So, which is equal to 1 by 13 into adjoint A matrix. 2 minus 5, 3 minus 1. I hope you understand this, students. Sir, please cover the calculus portion by the end of August. Yes, sure, I can. As soon as completing this topic, I will start that calculus part. Calculus part, which topic you want, means that only I will calculus second year, which part if you want, that I can assure dear students. Here, one important property regarding adjoint and in second bit is important point. If A is a square matrix, if A is a matrix, is any square matrix, of order n, then A into adjoint A is equal to adjoint A into A is equal to det A into identity matrix. This is very, very, very important formula, dear students. Sometimes they are asking to prove this result. Oh. Yeah, Sandeep, hi Sandeep. I will make it surely. In that calculus part, which portion you want exactly that you mentioned, I will cover that. Surely I will. So, in this question number 1. If A equal to 2, 3, minus 4, minus 6, verify A into adjoint A equal to, yeah, Bihari Gaming, thank you for joining. Please support. It will help for CBSE 12th class itself. First, to prove this result, we need to calculate determinant of this matrix. What is the determinant of matrix? A equal to given 2, 3, minus 4, minus 6. That implies det A equal to 2 into minus 6 minus 4 into 3. So, which is equal to minus 12 plus 12, 0. Yeah, integrals and application of integrals. Sure, dear students. Once you go to the playlist, but not exactly AP intermediate, but the questions I covered all differential equations completed, integration completed, area of integration completed. You can go to the playlist of this channel. You can get all that integration. Even AP intermediate heading also I will keep, and I will explain. But NCRT questions, same NCRT questions only, which are CBSE questions only. So that is the reason, once again I am telling Sandeep, I already explained integrals and application of integrals, but once again I will explain in notes. That is on board I explained. Once again I will explain on the notebook. Sure. Okay. You can share to your friends also about this channel. You can subscribe, and I will help you in coming days. So det 0, dear students, det 0 means no need of A and adjoint A. Adjoint A we can calculate. Adjoint A means what? Interchanging of diagonal elements and sign changing of. Sir, మీరు తెలుగు. Yes. Are you from? 4 minus 3. So I am verifying first A into adjoint A. A into adjoint A. So A matrix is 2, 3, minus 4, minus 6. Adjoint A, minus 6, minus 3, 4, 2. So matrix multiplication, 2 into minus 6, minus 12, plus 12. Minus 6, plus 6. Plus 24, minus 24. Plus 12, minus 12. Bihari game, you are from Bihar. Okay. Thank you, dear students, for joining the session. Please like and share. If you like this video, it reaches to more students. That's my intention to tell you. Thank you. Thank you for your support. Next, adjoint A into A. You can. So, adjoint A into A. So, adjoint of A, I already wrote that. Minus 6, 2, minus 3, 4 into A matrix 2, 3, minus 4, minus 6. If we do that product, minus 12 plus 12, minus 18 plus 18, 8 minus 8, 12 minus 12. So all zeros. So that is 0. Equation number 2. And det A into I. Det A means 0 we got into I. Identity matrix 1 0 0 0. Even if you multiply 0 0 0 will come. Equation number 3. From 1, 2 and 3 we conclude that A into adjoint A, which is equal to adjoint A into A, is equal to det A into I. Hence verified. Hence verified. Okay, dear students, this is the way we can prove. Next, for 3 by 3 matrix, we need to do in the similar way. Similar way, we can do it. Till second question, I will. After that, even in my other channel, Maths with Panindra, you have Telangana and AP Maths 1A, Maths 1B, Maths 2A, Maths 2B is also available, dear students, if you want. So second bit, question number 2. If A equal to 1 minus 1, 2, 3, 0 minus 2, 1, 0, 3. Verify A into adjoint A equal to adjoint A into A is equal to det A into I. So before verifying, we need to calculate a determinant of this matrix. Okay. So first calculate determinant of A. So det A equal to 1 into direct line, eliminating of this row and this column, 0 minus 0. Next here plus minus plus will be there. No? So plus 1 into eliminating of this column and this row, 9 plus 2. Next plus 2 into 0 minus 0. So 0 plus 11 plus 0, that is equal to 11. So det A equal to 11. Okay. Later adjoint A we can calculate it. For 3 by 3 matrix, I wrote that shortcut method here, adjoint A. So this is the way is best, adjoint A shortcut method. Adjoint of A is equal to, see, generally adjoint A means cofactors transpose. So start from A2 to element. So 0, minus 2, 3, again 0. Next 0, 3, 1, 0, minus 1, 2, 1, minus 1. Next again first we have to write 0, minus 2, 3, 0. We know that how to expand determinants of these. Zero minus 0. Next minus 2 minus 9 minus 11. Minus 2 minus 9 0 0. Next 0 minus of minus 3 plus 3. 3 minus 2 1. Minus 1 minus 0. 2 minus 0. 6 minus of minus 2. 6 plus 2 8. 0 minus of minus 3 plus 3. So transpose of this matrix. Therefore adjoint A is equal to 0, 3, 2, minus 11, 1, 8, 0, minus 1, 3. Now come to one by one. A into adjoint A. So A into adjoint A. So what is A matrix? 1 minus 1 2, 3 0 minus 2, 1 0 3 into adjoint A. 0 3 2 minus 11 1 8, 0 minus 1 3. So multiply, dear students. 0, 11, 0. Directly I am writing. 3 minus 1 minus 3. 0. 2 minus 8 plus 6. 8 plus 6, 8 minus 8, 0. Next, 0, 0, 0, 0. 9, 0 plus 2, 11. 6, 0 plus 2, 8, 0. 6 minus 6, 0. Once again I will write it. 3 3 is a 9. 9. Now second one is over now. 3 into 2, 6. 0 minus 6. 6 minus 6, 0. 0, 0, 0. 3, 0 minus 3, 0. 2, 0, 9. 2 plus 9, 11. Okay, dear students. Next, adjoint A into A. Equation number 1. Adjoint A into A. So just interchanging of these two matrices. 0, 3, 2. Minus 11, 1, 8. 0 minus 1, 3 into 1 minus 1, 2, 3, 0 minus 2, 1, 0, 3. 0, 9 plus 2, 11. 0, 0, 0. 0 minus 6 plus 6. Minus 11 plus 3 plus 8. 11 minus 11, 0. 11, 0, 0. So 11 plus 0 plus 0 is 11. Minus 22, minus 2 plus 24. Minus 22 plus 24, 0. 0, minus 3 plus 3. 0, 0, 0. 0 plus 2 plus 9. 9 plus 2, 11. Equation number 2. Next, det A into I. What is det A? We got det A value is 11. 11 into I, identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So which is equal to 11, 0, 0, 0, 11, 0, 0, 0, 11. Equation number 3. From 1 and 2 and 3, from 1, 2 and 3, we conclude that A into adjoint A is equal to adjoint A into A is equal to det A into I. Hence verified. Okay, dear students. The next questions, inverse of a matrix and verifying AB whole inverse equal to B inverse into A inverse. All these questions we will discuss in the next video. Thank you for your support. Jai Hind. Thank you for your support, dear students. Whatever you want, the respective topics and concepts, you write in the comment box in my free time. I will help you. Yeah. Thank you, dear students. You are from Vizag. Thank you, Mr. Sandeep. I already discussed with you. If you want integral right now, you can go to this channel and the playlist you can verify. All integration problems exercise wise will be there. Otherwise, if you want, after completing of this determinant, I will start. Okay, dear students. Thank you. Yeah, I'm going to end the session, dear students. Thank you. It is not closing. I don't know for what reason.